Good morning, welcome to
FamilyMath number 105.
FamilyMath number 105. We found a really cool thing on the internet when I was in London last week. And so we're going to try to go through it quick. It's from, remember James Tanton? He has a lot of really neat stuff, right?
Yeah.
He's talked about base 1.5, or what fraction is 1.5?
3 halves.
3 halves, or 3 halves. Okay, so a long time ago with both of you guys, I did a binary adding machine. So in binary, the digits represent 1s, 2s, 4s, 8s, etc. And we used red blocks to represent 0s, white blocks to represent 1s.
Yeah.
And we had one very simple rule, that 2 1s on top of each other turned into a 1 0. Like that.
Yeah, because 1 0 is 2.
Remember that?
Yeah.
Okay, so we could do a real quick demo of our binary adding machine. What's this number? 1 1 0 in binary?
That's 6.
That's 6, and then let's add the number. What number does this represent?
That represents 3.
Okay, and what was our rule? How did this? How did our binary adding machine work when we added these? What did we do?
Well, these two added together just gets us to 1.
Why is that?
Because 0 plus 1 is 1.
Right.
But these two gets us to 2.
Okay, those two got us a 2.
And then you have to make it a 1 0.
Well, hold on a second. We're not done. We're not done adding yet.
And then there's a 0 here. So
This just stays a 1. Okay, now we have to use our rule, which says this 2 turns into
A 1 0.
a 1, and go ahead, put the 0 in. 0. So now we have this number, and this 2 turns into a
1 0.
1 0. Okay. So our number 6 plus 3, which
would be 9.
9, it ends up being 8 plus 1,
Which
8
is
0 0 1, which is 9.
9.
Okay.
Cool.
But James Tanton has a really cool, different version of this. Okay, are you ready?
Yeah.
He says we're going to do the same thing, but our rule, instead of 2 turning into a 1 0, he's going to say, here's a new rule. 3 of them, hopefully that you can see that, 3 turns into a 2 0. And he says this represents base 3 halves. So the first thing we're going to do is just kind of play around with this, okay, and see if we can even just count. Okay, are you ready?
Yeah.
So this is our only rule now. 3 shifts over 1 and becomes a 2 0. Okay, does that make sense?
Yeah.
Okay, so let's just see. This is so neat just to play around with, and it's fun. I think this is really fun for kids. So if we just have one block, that's the number 1. What's 2? What's the number 2 going to be?
Well, 2 is gonna.
It can be 2 blocks.
2 can be 2 blocks. Okay, go ahead. That's the number 2. I'm going to try to smush these all in together. There's the number 1, then the number 2. Okay, what's the number 3 going to be?
It's gonna be 3 blocks, except it shifts over to become a 2 0.
3 is the number 2 0. Okay. 1, 2, 3. Maybe I should do it over here. So I think I'm going to run out of room. And 4? What's 4 going to be?
Well,
Will be 2 1.
There you go. 2 1. Okay. What's 5 going to be?
well,
It's just gonna be 2 2.
2 2. Good job. Now we're going to start getting pretty interesting. 6.
but
What is, well, first of all, what is 6?
6 is gonna be. It's gonna be 3 3.
Well, wait, we just have to put one block on. So where do we put it first?
Well, we put it over.
Put your finger on the thing we're going to put it on. This one.
Wait, yeah.
It's going to be 2 3.
2 3.
Okay, can you make a 3 for me? Okay, and what does our rule say that we do with the 3?
It shifts over to become a 2 0.
It becomes a 2, which goes on top here, and then a 0.
But now we have a 4.
Now we have a 4, but so what can we do with the 4?
Well, 4. You can use the 3 inside of a 4.
We can use the 3 inside of the 4, and that shifts over and becomes
2 0.
2 0. So 6 is 2 1 0. Oh, wow. Okay. Now let's just do a fun adding thing and see if we can add. Maybe we can add 4 plus 2. Okay.
Okay.
Isn't this neat?
Yeah.
All right. So let's do 2 1. That's the number 4, right?
Plus
2 1 0. 2 1 plus 2 1 0.
4 plus 6.
Okay, 4 plus 6. So this should somehow be the number 10, but we haven't really figured out totally how to count yet in this language. So what's it going to be when we add these together?
Well, you're gonna be adding a 1 to a 0, so this is 1.
Right?
But now you add these together, you get a 3.
Okay, awesome.
And you add those, you get a 2.
Okay, now is this a good number for us, or do we have some rules we can use?
We got a little 3.
Okay, what are we going to do with that 3?
Shift it over to a 2, 0.
Okay,
So
here's a 2,
and here's the 0.
0. Okay, now
Now
that we
we
got
got-
4 here.
Now let's use the 3 inside it.
Okay, show me what you do.
So 3, then it shifts over to become 2, 0.
Well, no. The 0 goes on here. Here, remember that 3 was there. So the 0 is left behind, but the 0 and the 1 leaves just a 1. And then I have a 2 here. So this should be 10. 2, 1, 0, 1. Whoa. And if we're trying to understand, he says this is base 3 halves. So this will be the 1's digit, the 3 halves digit, the 3 halves squared digit, which is what?
It's 9 fourths.
9 fourths. Okay. And then what's 3 halves cubed?
27 eighths.
All right, so now what this is saying is 2 times 27 eighths plus 1 times 9 fourths plus 1 should equal 10. Okay, what's 27 eighths times 2?
Well, you can simplify. Well, you can't simplify 27 eighths.
Well, you can simplify 27 eighths times 2. What is 27 eighths times 2?
It's 27 fourths.
27 fourths. Oops, 27 fourths. Can 9 fourths be simplified?
It's 9 halves.
Well, it's not times 2. It's just 1 times 9 fourths.
Then, no.
I don't think
Okay.
so.
9 fourths. And then plus 1.
Which is 4
I
fourths.
wrote 0. I meant 10 there. Okay, now what's 27 plus 9?
27 plus 9 is 36.
Okay, so we have 36 fourths plus 1, and we're hoping that this equals 10. 36 fourths plus 1, does this equal 10?
Well, 1 is 4 fourths.
Well, what is 36 fourths? What's 36 divided by 4?
It's 9.
9. 9 plus 1 is?
10.
How about that?
That's
Awesome.
cool.
I forgot to write the 1.
Oh, jeez, I'm too tired. I'm still in London time. How about that? So our magical little Duplo blocks, they knew how to add in binary,
Yeah.
and they also somehow know how to add in base 3 halves.
That is cool.
Yeah, all right. High five, guys. Good job. That was really neat. I like that a lot.